Good morning all. In this video we will be building a customer's LED controller board which has been purchased off eBay. The customer has requested that I program it for a certain amount of LEDs, so we'll do that later on in the video. But this video will show you how easy and how quick it is to build it if you're experienced with electronics. So let's get on with this. So we have the controller board and all the necessary components. First, we are going to mount the WeMOS and solder its connections, which is the easiest bit to do. This can be done on breadboard if you have breadboard, but I always find just placing it in there. Placing it in there like so. I know it's upside down, but it doesn't really matter at this moment. And then nice soldering iron and solder away. I always like to do the end pins first, just to make sure that everything is aligned correctly. So we'll take that back out again. Have a look, all the pins are straight, everything's sat down nicely. So we'll place it back in the board. And we'll carry on soldering. Always taking care not to short things out like I've just done. This is where a little bit of solder braid always comes in handy. So if you do get a short, you do link two legs together, a little bit of solder braid, just to remove the excess solder. Okay, we'll just zoom in on that a little bit, I think. There we go. Just zoom in on that for a moment. Place it in there so you can see. Okay, that should be good. Take a look at all the pins, make sure there's no shorts. Excellent, that's that part done. Now to assemble the board itself. It doesn't really matter which components you add at which time. What we'll do is we'll put the connectors on first. Hold them down a little bit of blue tack. Make sure they're facing forward. Plenty of heat on these because one is connected to the ground plane, which is a big copper area on the board. So just a little bit of extra heat just to make sure the solder flows correctly. There. Bit of extra heat. There we go. Lovely. Let's put the WeMOS pins in. But what we can do with this one is if we fit them to the WeMOS first, helps for alignment. It doesn't matter which way you put it in, just the moment. We do that. We put them on standoffs so it's easy to remove the WeMOS, plus there's actually components underneath as well. But the main thing is to make sure that you can remove the WeMOS if you have any troubles. But you want to program it off the board. So, once again, soldering iron. Don't need to keep it too long on the board. Just enough to make sure that the connection is properly soldered. Some of the ground pins will take a little bit more heat. That's due to the copper area on the board again. And there, that's the WeMOS soldered. Yep, everything's good. Take the blue tack off, inspect it for, make sure there's no solder bridges, and we'll remove the WeMOS just for now. Next thing, we'll place the IC base in. You don't necessarily have to have an IC base, but it always makes for good practice. Should anything go wrong with the IC, it's easy to remove it. So we'll just make sure the cutout of the IC base is, you can see, corresponding to the cutout at the top. A little bit of blue tack, clean the solder iron, and solder that in place. And there we go, we've jumped a lot. Missed one there. Right. And again, some of these pins may require a little bit more heat due to them being on the copper plane. Okay, that's the IC base in nicely. Right, let's fit some of these. Let's fit some of these capacitors now. Just passive capacitors, that's all. But they're there to help the WeMOS stay stable. So you can use blue tack to hold these in, but I just normally just bend the legs. Just bend the legs outwards like that. It just helps. Just keeps them in place. And then we can solder these in all in one go. Okay. Down there. And we'll solder these in. And soldered in like so. Just verify that all the components are seated correctly. Everything looks nice. And then we can just snip off the excess wire. Some nice sharp side cutters. I know there's another YouTuber out there that always likes to save his ends of the wires he cuts. It's always handy. Okay, we'll do just a quick inspection, make sure there's nothing shorted there. Right, let's add the two resistors. So we have two resistors needed. One is a 10k, the other is a 220 ohm. So the 10k lives here. K lives in there. So once again, put it in, push it down, pull the legs apart a little bit, hold it in place. 220 ohm lives in this position up here for R2. Again, everything's seated nicely. Back to the solder iron. Once again, cut off the excess. And that's the resistors soldered in. Okay, just a few more components left. We'll do the capacitors, the electrolytics next. So we have a nice 1000 mic. Now these are polarity dependent, so you'll see down the side of the capacitor there's a negative stripe, so the negative stripe goes to the side, so the other side must be positive. That goes to the plus on the board. Pop that down like that, making sure negative is correct. Again, turn it over, splay the legs apart. But on this one, a little bit of blue tag, just keeps it nice and close to the board. Once again, a little bit more heat may be needed for one side of this. Oops. Cut off the excess. Verify we've installed it correctly. Positive, negative. That's good. Now the next one is a little bit more fiddly. So what we'll do is we'll cut it out of its tape. And I forgot to get some low nose pliers. So we do need to straighten these legs just a little bit. Whoops. So we'll just straighten the legs out just a little bit. It's due to the holes on the board being quite small for this. And again, one side is marked negative. So we'll look on the board. The right hand side there is positive. So we'll switch the capacitor around, verifying that negative goes to the negative side. Just drop it in like that. Splay the legs apart a little bit of blue tack just to hold it into place. Now this can be quite fiddly with the soldering iron due to them being quite close together, so always be wary of solder bridges. That's that one. Now the negative side one will need a little bit more heat. There. That's good. Once again, just trim off the excess. Verify there's no short circuit. That's good. We'll do a short circuit test anyway before we install the main components. Okay, and last but not least, the main 3.3 volt regulator with its heatsink. I've already attached the regulator to the heatsink, but it's as easy as just screwing it on with the insulating material. It's a 3.3 volt regulator, so we'll just pop that into the board there. And again, we can just splay the legs out just a little bit. And just to stop it wobbling, we'll just put a little piece of blue tack on, like so. Now this will require quite a bit more heat due to it being on a heat sink. Especially this end pin that's connected to the copper ground plane. We'll just leave that on for a few more seconds just to make sure that it is a good solder connection. Okay, that's good. And once again, we can trim off the excess. And that's the components on the board fitted. So what we'll do first is we will do a test to see whether it powers up correctly and whether the regulators are operational. So on the top of the board we've got negative and plus 5 volts. So I'm just going to tack a piece of wire into here. And a piece of wire for the plus 5. Making sure we've got the correct polarity. Okay, I'm using a bench power supply for this. Just move my soldering iron so I don't burn myself. So I'm using a bench power supply set to 5 volts. Connect to negative and just briefly touch the positive, watching the current reading. No excess current being drawn, which is good. So what we'll do is we'll just do a quick voltage check with the meter. Just to make sure that everything's correct. So we should have 5 volts. One of these pins. There it is. There's the 5 volts correctly there. And if we turn over, put our probe on the negative, and there should be this pin for the 3.3, 3.28. Okay, so the regulator's operational. Don't need the meter now. Okay, we'll just turn it off. Take the wires from the bench power supply. Now we can fit the WeMOS. Just double checking that there is no short circuits. So we can plug the WeMOS in there, following the legend on the board. Plus this all makes it easier to program on the board should you wish to do that. Now the level shifter IC, it has a notch at the very top. You can see that. So what I like to do is just on one side, just bend the legs down just a little bit, following the notch at the top. carefully place the IC into the socket, making sure that the pins are actually going into the socket itself. Quick visual inspection and push down into place. And there is the board constructed. Now let's test the board. So I just need to clean the work surface. So we can get some lights into show. Now the lights I'm using are WS 2811s in a string off eBay. Now this customer wanted 25, so I'll just put the first few into show. I'll move the camera in a second. Now there's 3 wires on these lights. There's a positive supply, a negative supply, and the data line itself for the LEDs. So what I'll do is we'll just strip back a little bit of the wire. I know this is a little bit crude for testing, but this is only testing phase. Once you mount it in whatever enclosure you like, you can always tidy the wires up accordingly. So negative to negative, positive to positive, we'll just twist them together. It's usually the center wire on the LEDs that's the data line. If unsure, you can look down the side of the LED and it usually says 5 volts ground and D, and the LEDs have a direction as well. Usually there's an arrow to show you which way the data is, so if you're daisy chaining more than a few LEDs, just always make sure you get the arrows correctly orientated. So back to the WeMOS board, we place the data line into the D connector. Now the other side of the data connector can be used as a negative. It's there just in case you need to bring a negative 2 next to the plug or whichever you're using. So next we need a USB cable. So it's just a standard micro USB. Just a standard micro USB cable. We'll plug this into the computer. Now with this being a brand new WeMOS, it should have a blink routine on it. There we go. Right, now ignore the red LED, that's actually a faulty one. And we're blinking. You can see the light going on and off. So we'll move to the Arduino, or the ESP should we say. Now on the Arduino itself, or the ESP, so pin 13 we are using, so that's the Arduino pin 13, so that actually corresponds to D7 on the ESP. It's up here, should you wish to see that. Okay, so pin 13, so number of LEDs. So this customer specified, oops, no, specified 25. 25. We'll set the brightness to 200. You can obviously set that to whichever you require. Now, the other important piece is this Neopixel LED command. Now, there's two there, one for an 8x8 Neopixel, which uses a 2812 LEDs, and you'll find that the green and red are back to front from the LED rope. So it's not too important really if you're just doing effects, but if you want something to show red, then you need to make sure that this is set correctly for your LEDs. In the Arduino itself, in the Neopixel, there is some test routines that will show red, green and blue, so you can actually find out which way round. But these LED ropes off eBay use this RGB. As you can see, the 8x8 uses GRB. So ours is that. So brightness, number of LEDs, 25, and we'll hit upload. And fingers crossed, it should upload. I always find sometimes these ESPs can be a little bit twitchy when you're programming them. So if it doesn't work first time, retry it again. If it still doesn't work, power it off, power it back on again. There we go, and it's programming. There we go. Okay, I've just worked out that I've just reprogrammed the one that's on the bench. So what we'll do is we'll unplug that and we'll actually reprogram the correct one this time. I have one on test. So port COM4, should have checked that first, that ours, and we'll upload again. There we go, and we're uploading. And there we go. We should have colour sequences now. So we'll go back to the camera. Turn off the light. We'll just bring the camera out just a little bit. Oops. There. So what we'll do is we'll just increase the brightness for this. So we'll put it as 255. Now on this test script we can hook up to the serial monitor as well. And we can see which sequence is playing. That's better, it's a bit brighter now. Go to serial monitor. Oh, you can't see the serial monitor on here. Okay, I know the effect doesn't show very well on film, but when you get a longer string of LEDs, the effects can be quite nice, especially when it swipes from side to side and from the middle to the outsides. At the moment this is on a rainbow cycle, so it'll cycle through all the colours in a chasing pattern. I know you can't see it very well on the bench, but there's other effects there as well, like strobes and Yeah, it looks much better when you actually get a longer string of LEDs and actually position them. But that's it. That's how you make the ESP8266 LED controller board and program it. All the information can be found below. Links to the eBay listing can be found below for a pre-built board and a kit board. That's a rainbow cycle, so you can see it's cycling through different colours. There's a link to the website, which has got the schematic and the parts list, should you need to see which parts. There is one other thing that we haven't done on this board, which is just an optional extra. At the very top, there's an OLED connector. So if you wanted to add a small OLED screen or an LCD screen, or basically anything that runs on the I2C data lines, you can connect it to there. It's got a connection to the 3.3 volts. And the negative, if you need 5 volts, and you just have to tap it off from the input for the LCDs. I've got an LCD somewhere that requires 5 volts, which I'm going to play with sometime. One of these that's on the I2C line. So you can fit an OLED display if you want to show colours or any other information. Just remember that this is a basic test script, and basically the world is your oyster when it comes to the programming, because the main part of this board is the actual software and the actual Neopixel. It will work with fast LED, of course, because the hardware is exactly the same. It's just down to programming. There are many examples on the internet of programming fast LED, programming fast Neopixel animations, and it's a perfect thing for Christmas lights, which is the ultimate goal of why I built these in the first place, was to make a unique Christmas light display. Okay, well that's everything. We've built the board, we've tested it, we've programmed it, we've gone through all the components, and I hope you have fun with your board. Any feedback is obviously greatly appreciated. Thank you for watching. Subscribe, like, share, thumbs up, leave a comment, anything you wish really. Thank you and goodbye.